The Queen Space Engineering team is made up of 3 technical sub-teams, the mechanical, electrical, and science team, and 2 logistical teams, PR and sponsorship. The mechanical sub-team focuses on the chassis, drivetrain, and end effectors of the rover, while the electrical team focuses on printed circuit boards, electrical control systems, and communication systems.
The science team has come a far way since our inaugural year in the fall of 2014. We began the year completing research in the areas of current Mars missions, Martian geology, chemistry, and the implications of the newly discovered water.
Our rover uses an A-arm suspension system similar to that we've used in past years. The reason we use an A-arm suspension system is because of its ability to handle rough terrain as well as its simplicity as compared to a rocker bogie suspension. It was chosen based off of these metrics in order to reduce the likelihood of failure during competition. Once tested with our old mounting brackets, we realized the camber of the wheels was angled too much. This led to the design and fabrication of new mounting brackets. This ultimately led to the design of the final suspension. Similar to the past years, we use aluminum extrusion for the chassis. The use of aluminum extrusion allows for designs to be iterated very quickly. In addition to this, the aluminum extrusion also allows for a highly modular rover, allowing for easy interchangeable components in between tasks. Beach wheels were chosen again this year for their performance achieved last year at competition. They enabled for good movement over sandy terrain, as well as suspension and grip when going off of drops and going over boulders.
For the geology task, the rover will feature a clamp end effector for picking up rocks and measuring the sizes of rocks, as well as a scoop for topsoil and subsurface sample retrieval. The subsurface will be taken by first scraping away at the topsoil, dumping that at another site, and then taking a deeper sample that we can then store. Samples taken using the scoop will be stored in our 5-sample carousel that features the ability to measure the weight of each sample independently, as well as seal each sample for later analysis. For communication between the rover and base station, we are using 2 Rocket M2s by Ubiquiti operating at 2.4 gigahertz with 2 8 dB antennas mounted on both.
At the heart of our rover is a Raspberry Pi 2, which manages the network connection as well as the control of all external sensor, servo, and motor ports. Control of these systems is performed by the Pi through a slave Arduino Mega. All of these external connections are facilitated by brand new printed PCBs. These provide a standardized way for us to interface with a plethora of external sensors and control devices at various voltages and currents, while having the added benefit of reducing clutter of the rover's internal connections. The external cameras are interfaced directly with the GPU of the Pi, providing near real-time video at HD quality with little to no processing overhead on the Pi. The software used to control the rover has been completely redone this year, and is instead served as an HTML5 web page. This allows for on-the-fly changes to the rover while also allowing multi-user access. For example, it will be possible for the science team to take sensor readings while the driver simultaneously pilots the rover.
For emergency systems, the team is ensuring a policy that whenever in operation, someone will be following the rover in case of any accident so that we can instantly cut off the rover with this emergency power stop. The switch can operate up to 250 amps of surge current, so any case that the rover's in, it can be immediately shut off and ensure safe operation.
At QSET, we believe that space exploration is the next great feat for mankind.